So I'm over at my parents' house. I'm helping them do the utilities, the plumbing and electric. We're going to start with the electric because that's the most important for them to get it done the quickest. Right now they're running extension cords over here, so it's important to get at least a few outlets put in. The whole house has an electrical rough-in and it's inspected. So now we can just start hooking up a few circuits here and there. Put a few circuits down here just so that there's not so many extension cords going out, windows and doors and stuff. Going to be installing a 200 amp service. Going to be using a square D home line panel with the plug-on neutral, which is very convenient. Right now the service cable coming in is 4/0 URD for the 2 hots, 2/0 for the neutral, and if I remember correctly, I think it was number 2 for the ground. It's aluminum. So since there's already a pedestal meter outside, this is actually considered a sub panel, so you can't connect the neutrals and the grounds together. They have to be all separated. So you don't want to put the bond screw in, but you do need to bond the panel to the ground. So if you look at the fill rating for a regular 2-inch LB, which is what I need to bend that corner right there, it's not enough for this size conductors. So what you need to do is get a 2.5-inch LB and then convert it down, going in and out of it, down to 2-inch. This is massive compared to a 2-inch LB, but this is what you need. And it also makes life a lot easier when you got to bend the conductors around this corner too. So when my dad was doing his backfill, he put in this conduit here and he didn't really know where to put it. So we need to trim it down flush to this ICF wall right here. And then that way the flange to the LB can go into there and be at a nice straight line going over to the panel. So to cut this with the wire still in it, you can do it, it's just you got to be very careful. You just take a flexible saw like this. You just keep cutting all the way around, and you just gotta pay attention to the depth and make sure you don't go any further than it is thick. And then once you get most of the way around, then it'll just snap right off. That way you're never really cutting into the pipe, you're just cutting most of it. Just check the wires, make sure there's no damage to them, which there's not. And there's some water coming out of this conduit, mainly because it's been sitting here for at least 6 months. When they dug it up over there to open air, and condensation and everything else gets water in it. So it's kind of draining a little bit of the water out. My dad wanted to go right into the back of the panel right there, but I told him put an LB there, because if you ever do have a water problem where you get some water in there, you don't want that water going into your panel. And so by having an LB there, you can drill a hole in the bottom of the LB, and then that way any water that's coming into it can just drop down before it ever gets into the panel. And you'd be surprised how often you can get water into there, even with just condensation. You certainly don't want that dripping over your breakers. I like to put these big lag screws in because these are really strong. They're structural. Although not required, I always like to put this on from the connection from the conductor to the service lug. I always like to leave a loop going around the top for thermal expansion. That way as the wire is heating up, it can push or pull. So they have another lug right here for a ground, but I can't use that because it's connected to the neutral. There's no way to separate it. So what you have to do on these panels is buy a separate ground bus. One on this side, one on this side, and then I also like to put one on the bottom here. That gives you lots of grounding. But now all these bus bars are for the neutral. And what's nice about that is it has a plug-on neutral. So every time you go to put an arc fault breaker in here, or an arc fault, ground fault, dual function breaker, it will plug onto this for the neutral. And then that way you don't have to run that separate pigtail to the neutral, which also saves a lot of space in here too, and declutters it a lot. So now instead of going to the bus bar with the neutral, now you're going into the arc fault breaker, which a majority of the breakers in here are going to be either an arc fault or an arc fault, ground fault, dual function.
I'm gonna guess probably by tomorrow. What? By tomorrow.
It's gotta be right here. Yeah, turn. I was using.
Oh, this one. Oh, this one. Yeah, that'll be.
All right, so down in the basement we have 2 bathrooms. They're kind of back to back. This is the toilet for the one, that's the toilet for the other. This is going to be the sink for in this one. There's the tub, and over there is going to be the sink for the other one. There's 2 bathrooms. There's one right there and one right here. And this is going to be a shower. So originally when they were designing this house, it was supposed to be for a 1-bedroom plus a music room. And then after they got the plans, it was changed to a 2-bedroom. So the space changed a lot. So these bathrooms became a lot smaller. I think originally it was only supposed to be a 1.5 bath, and now it's a 2 bath. So those 2 things together kind of made these bathrooms extremely small. But my parents lived in a house before that the bathroom was even smaller than these, so they're fine with this. So the septic's going to go over there on that side of the house, and there's going to be a room over here that's framed up underneath of this LVL beam here. And so basically what we're going to do is come over and over top of this LVL beam, and there's going to be the main septic line going down that way, 3-inch, and everything's going to tie into it going like this. I could tie things together going across the joist, but for the cost of a little bit more pipe, I'm just going to go down each bay with each one of them instead of trying to cross. You can technically do that. The notching and boring codes will allow you to notch and bore a lot out of these joists, but it's just better not to if you don't have to. So my dad and me both agreed that for the price of a few extra feet of pipe, it's not worth doing all that. It makes it a lot easier doing it like that too, because then you don't have to drill through the joist. And when you drill through the joist, you got to make sure you're like really precise anyway. So it's just all around better to just kind of shoot over there with all of them. So I always like to try to take care of the toilets first. And so the first one I'm going to do is that one. So that needs to shoot over here, over top of that beam. So I'm going to wet vent that toilet from that vanity. So at that vanity, I need to go up with 2-inch pipe until I get to the T where it goes to the actual drain line in the sink. And then from there up, I can go 1.5 inches. Normally you just go up with 1.5 inches there. A lavatory in a bathroom only requires 1.5 inch pipe, but because we're wet venting it, you need to bump it up to the next size, which is 2-inch. And you can never put a sanitary T on its side unless you're just venting there and you're not putting any drain into it. You can do it then, but otherwise it needs to come out with a Y and a 45 to go up. So now that we got 2 toilets roughed in and 1 lavatory, over here, there's gonna be another lav, which is gonna be a pedestal sink coming up in the corner there. So again, I'm gonna wet vent from there over to here, which is the tub. So we're gonna run 2-inch, because that only needs to be 1.5 inches for that lav there. So we're gonna upgrade that to 2-inch so it becomes a wet vent for this tub. Since this is going to be exposed here, you can put a flange nut trap on here. That way you can swivel it back and forth. You can swivel it on that point where the union nut is. And I have everything set at the right angle so that no matter where you swivel that, it'll always be plumb going up. But now I can continue on this 2-inch pipe and connect it into the main septic line going down.
For us, it isn't gonna do shit for us, 'cause we don't pay anything.
Well, I believe there's the option to do it off for several years if you want, but what
If you said, oh no, you get money back, like an earned income credit.
So all the drains are hooked up from there to right there. There's gonna be a washing machine right here. So I do need to come out with a standpipe and a P-trap for that. I also need to vent that P-trap. So there's gonna be one more vent somewhere in here. And then my dad also has it set up so in the future there could be a bathroom here. He did all the plumbing. He's probably not gonna do that for a long time though, but we can also tie into that vent for that bathroom too. So there's gonna be 5 vents altogether. The one right there that's gonna go up for the washing machine and future downstairs bathroom. There's one right there that needs to go directly up. There's gonna be one right there. That's gonna be a sink converted to 1.5 inches above the T. So that'll go straight up into the ceiling. There's another one right here for the toilet. And then the last one is this other sink right here that needs to as well get converted to 1.5 inches above the T and go straight up. So we're gonna go up with all 5 vents, 1.5 inches into the ceiling, and then convert it to 3-inch and go out the roof. So normally with 2 bathrooms like this, you could get away with 2 or 3 vents that goes up to the ceiling and then gets converted to 3-inch, but just the way things worked out with the layout, I wasn't able to combine vents close enough. So a lot of things are individually vented, which is not a bad thing. It's just a little bit extra work, a little bit extra pipe, but there's no problem with that. We'll combine them all in the roof and then go out the roof with just one 3-inch pipe. So with this sink, directly above that is a ceiling joist running right over top of that wall. So we can't go straight up with it. So we're gonna go up, over, and then we gotta bend around this corner, and then we'll meet up with this vent right here and then go up from there. It's not ideal to do this. Trying to go around a corner like this is not ideal at all, but it can be done, and it's really the only option here. I think the only other thing you could do is reframe up there. Take that joist out, put 2 joists on both sides, block it out, and do all kinds of crazy stuff like that. But I could make going around the corner work a lot easier and quicker, even though it's not ideal. The other thing you have to think about when you're running vents like this is they still have to be sloped. It either has to be sloped back this way, or if you're going this way, you could slope it all downhill this way to go back down this way. Either way, you need to be able to drain the condensation one way or the other. And I don't think the code addresses this, the IPC. I don't think they address the actual amount that you're supposed to slope it, but it's just a good practice to make it 1/4 inch per foot. And there is a few outlet boxes that I need to avoid, so I need to do an offset and bring it back. So that outlet right there will need to come up, do a 45, another 45, and then go straight up from there. And then we can go over and then tee into that vent over there. And remember, you can't go horizontal with the vent until you're 6 inches above the floodplain, which with the sink is somewhere around right here. But if you use a 45, that's not considered horizontal. So you could, in theory, do this to offset it right above here. That wouldn't be a problem, but we can just put this up here and be above the floodplain. Either way is fine. But there's no reason why I can't just do it like this instead of putting it down here. The only reason would be that you could go into here with a street like this and come out of that with another street too, which I don't have right here, but you could do that with 2 streets, but there's really not much advantage to doing that. But coming out of this with something like that, you couldn't do, because that would be going horizontal. So now I'm going to come up from this vent right here and meet up with that one going around the corner. And I'm going to put a T here. And this sand T you want like this. You don't want it like this. You want the flow to go upwards, not downwards, for the water as well as the airflow. And again, I got a joist in my way up there, so I couldn't be exactly in line with this vent going all the way up. So I'm just going to meet up here, and then right after this I'll 45 over and offset it a few inches just to get up to there. So there is one last drain that we need to hook up in here. The kitchen sink is going to go right here underneath this window. So we're going to run up beside the window to go down for the drain and up for the vent. And we're going to come off of that with a trap arm that's going to go right in the middle for the sink. That's a pretty common thing to do. A lot of people put a window above the sink. So obviously you can't go straight up. Technically, if you work things out right, you could go over above the trap entrance with a 45 for the vent and then go up, but nobody ever does that. You just go up and down with the vent and drain and go over with the trap arm. You always want to remember to pitch this slightly this way so that coming out has a little bit of a pitch going into it too. And then of course you need pitch from there to there, which I'll just shim that out, give it something like that. Take this out right now. So basically what I had to do here was offset this, because below this floor it changes to an 8-inch foundation, and this is only a 6-inch wall right here, and the ledger board for the floor joist rests on that offset in the ICFs. So I just offset it like that, and then luckily this is the non-load bearing side. This is basically just a nailer This joist that's in here is just a nailer. It's not a ledger board that's holding up the joist going this way. That wall, if we had the sink in there, would be different. But I'll put this piece back in and show you what it looks like from below. So you can see the two foundations, they offset, and that's all we had to do. Now I can just do a long sweep around this way, go around there, all the way around to over to there where the main drain is right now, and then the septic exits the building somewhere's right there. I try to use long sweeps whenever I can. This is a long sweep here. And these are just street 45s here. So there's no extra joints where not needed. It would have been nice to do a long sweep here, but what that does is bring the middle of this bend out past the wall. And it just makes it a really sloppy looking connection. So just a regular sweep there. So what I'm gonna do now is secure this in place before I go any further. So what I'll do is put a couple boards going across and just attach to these webs here, and then I'll spot foam this in different places. And whenever you do that, when you put the foam behind the pipe, it pushes the pipe out when the foam expands. So that's why I like to put those boards to hold it in until that's cured. Once the spot foam is dry, then I'll take those boards out and just fill in everything, make it solid foam everywhere, and then we can put our metal plates over that. But for right now, I just want to secure it in place just so that my vent going up as well as the connection going down and across is not moving around. Alright, so I shimmed this all out so that it's good depth-wise, left and right, up and down, on the pitch. Everything is set exactly where it needs to be with shims. You know, I even put shims back here to make sure that it was back all the way. And then I shimmed up this side to be 1/4 inch per foot going to here. And of course, when you want to raise this side, it wants to raise this side because nothing is securing it down there. So then you put shims here to lower this end down. So it kind of tilts it like that. That's the trap arm. So it's a little bit more than spot foaming it, it's just foaming it wherever I can. So I'll let this cure for a little while, take out everything, and then fill in the blanks, and then we can move on from there. So now I'm going to install the 1.5" pipe going from the kitchen sink all the way around to the drain.
Because if you go this way, it wants to skip.
So I would have rather came in here with a Santee instead of a Y, just so I don't have to have that 45 right there. But the way it worked out was that I was too low right there to come over to here. And then, of course, when you got to here, I was too high over here to go directly in with a Santee here. But it's not a bad thing. Coming in with a Y is not a problem or anything. It just looks better with a Santee. There was really not another great way to do this because the stairs are right up against the beam here, so I couldn't come over from the sink and hit the beam and go down this way. I could have gone on the other side of the beam, but there's gonna be a room right there that's gonna be somewhat finished. So I didn't want it running on this side of the beam. And once I cross over the beam to this side, then I can't go back up over it. So it would have to stay on this side. So it does run over the door here, but this is not gonna be a finished room, so it doesn't really matter. And I asked my dad about it and he said it was fine. The problem is it's almost 40 feet, so that's a foot of pitch from one end to the other. All right, so we got the kitchen sink coming in. This is the main line coming from the rest of the house. This is gonna be for a sewage pump, an ejector pump right there for this bathroom right here. It's probably not gonna get hooked up for a long time, so we're gonna put a cap on there for now. After he gets a CO, a few years down the road, maybe he'll install that bathroom and then we'll tie in right there. But for inspection purposes, and for CO purposes, that's installed now. And then down here I got a flush clean out. That's where I'm gonna install my test plug. It's gonna be a balloon that inflates and stops all the water to that point. The only thing left down here that we have to hook up is gonna be the P-trap and standpipe for the washing machine, which is gonna go right there. But the problem is, until I install the septic system, I don't know exactly where we're gonna go out of the building. So my dad installed a knockout right there for the septic, but we're almost thinking that that might be too low because we didn't really do all the calculations to know where the tank is gonna go. I think that's gonna be raised up at least a foot, maybe even more. So until we do that, I don't wanna put in the P-trap and standpipe for the washer because you can only have the P-trap a maximum of 18 inches off the floor. So if that drain ends up 2 feet off the floor, then we can't go into that drain with the P-trap. And at that point, what we're gonna have to do is run a 2-inch pipe over to here into the ejector pump, and then the ejector pump's gonna have to come out with the 2-inch pipe back in right there. So then we'll be hooking that up before the CO. But we'll have to see how it works out, because if we're below where we're required to be for maximum height on the standpipe, or actually the P-trap on the 2-inch for the washing machine, then we'll just hook directly into it. But there's no sense in me hooking that up right now and then figuring out that it's gonna be different later. So we're done up to this point, so we'll put that plug in there and test it after I get the rest of the vents hooked up in the attic. And then there's this vent here for this bathroom, as well as venting that P-trap for the washing machine. So we'll have to hook that up. So we'll have to just cap this off for now, because we don't want to hook that up anywhere over here because we don't know where we're going to be yet. So we'll just cap that off for now, hook it up into the attic so it gets filled with water to test it, and then later on we can hook it in. And I'm gonna be doing the septic pretty soon here. I'm just waiting on some things with my excavator, so in the next few weeks I'll be installing that septic system and we'll know exactly where that P-trap needs to be. But for now, we'll go up into the attic and tie everything all together and go out the roof. And I installed this clean out at a slight angle this way because there's going to be a wall right here, so I don't want it like right up against the wall. So it's slightly off the wall so that you can have a good angle going into it. Alright, so we're up here in the attic and we got that vent right there, got that one right there, got that one right there, got that one right there, and then the new one that I installed is all the way right there. That's for the kitchen. So we got to tie all these together, and we got to tie them together in a way where they slope one way or the other to drain. I'm probably going to exit the roof over there because this is an 8-pitch roof. Both sides are 8-pitch, but then there's the porch that connects with a much lower slope roof. Somewhere is right about there. So that's a place where you can actually stand without falling off the roof. Over here, it's barely walkable because it's 8-pitch. And there it is too, but you can stand just below it right there. So we'll probably end up putting the vent somewhere right here. All right, so everything is all hooked in here. We got straps every 5 feet or less. Not exactly the prettiest work, but it's just vent pipes. And by going at a diagonal like that, you're using less pipe. So we tied everything together, like those two tie together in 1.5 inches. But then from there, everything else kind of goes in separately. So the kitchen is separate, the laundry is separate. According to the IPC, the International Plumbing Code, I could actually put 2 vents in and be good for everything. So one would be like on the laundry and the kitchen sink, and then the other would be the 2 bathroom groups here. I could do that by code, but I actually separated it into 3 vents coming in. So now that's 3 inch and we'll go through the roof. So to do this, I'm gonna level up from here, both left and right and up and down, do a crisscross, drill a hole right in the center where I want, leave the drill bit sticking out of the roof, and then I'll go up on the roof, take the shingles off, and then cut out for the plywood where I need, and then we can flash that in and put the boot in there. So since this is going to be like a 2-man operation to get that vent pipe nice and level and straight, brought Pat over with the telehandler just to make it a lot easier. It's a lot quicker going up and down the roof than it is with a ladder. So we're going to be poking through right about there, right above where it breaks, probably 4 or 5 feet above where it breaks for the porch roof. So it's a good thing we're doing this while it's still cold out, because these roofs can be very hot. So there's our screw. That's the center of where the pipe's going to be. So I'm going to take a 6-inch hole saw and cut out. But in the meantime, I'm going to take out some shingles there. I got this pitch hopper here. This makes it really convenient to be able to stand here because this is an 8-pitch. And you can walk on it, but it's not very comfortable. But you don't want to use that as fall protection. A lot of people always complain about fall protection, that I don't wear a harness and stuff. And if I need to wear a harness, I will. But in this case, like directly underneath me is the telehandler. And that's a 10-foot wide basket. So if I'm falling for some reason, which there's no reason to because this is only like a 3-pitch, this is going to catch me. So I usually set that up like that If I can't set up something on the bottom of a roof like this, then yes, I will wear fall protection. And I wouldn't suggest that for everybody, but I've been up on roofs so many times that this doesn't even faze me. All right, so that's all done. A lot of people like to hide this little lip underneath here, but to me it doesn't matter. You can't see this part of the roof from anywheres. So there was a break in the shingles directly above, so if I had picked the spot ahead of time, I wouldn't have picked it like that. But you saw me put that extra piece in here so that it's underneath of that, so that that break doesn't affect anything, because there's another piece that comes up like this. I've installed probably at least 100 of these boots in my lifetime, and I've never had any of them leak before, and I do them like this every time. So literally, as I'm coming off the roof, it starts downpouring. Perfect timing. If I had taken another 5 minutes, I would have been up there in the rain. So let's get this pipe secured from below. I just want to put a solid strap, metal strap actually, right onto the side into the rafter. That way there's no chance of this thing moving. And the only reason it would even think about moving is because I'm gonna fill everything up with water, so there's gonna be a lot of weight. So I wanna put the strap not just to hold it laterally, but to also hold it from up and down too. Because once you put a lot of water in here, it's gonna wanna sink everything down a little bit. I don't want it putting a lot of force down there, because that's exactly what it would do, is it would transfer the force onto those 1.5-inch pipes down there. So the space right there is a little bit less than 1.5 inches. It's like 1.25 inches. So I just took the skill saw and I just sort of turned it diagonal and just ripped a little bit here. Now it's perfect. I can almost hang off this and it's not pulling at all. So the only thing left to do up here, once we fill this pipe up with water, is to come up here and check for leaks, and that's it. And then my dad's gonna do blow-in insulation, so he'll be all ready to do that. The final step before testing this whole system out is gonna be putting caps on everything. Since this vent has nowhere to go right now, because I'm not going to hook it up to the laundry yet, because we don't know where that's going to be, what I'm going to do here is put a 90 and come over the top of that beam, and then I'm going to put a valve there with a little 1/2-inch PVC pipe coming out. That way we can test it, and then when we're done, we can just open that valve, let the water drain out. That way it's not full of water. These little 1/2-inch ball valves right here are like $3 or less. So it's easy enough to just put that in there, and then you don't have to worry about spending a bunch of money on an expensive ball valve. Just convert it up to 1.5 inches. So now that brings it outside of this wall that's going to be here, converts it down to 1/2 inch. I'll just shut this off. Now we can test it, and once we're done testing it, we can just put a bucket underneath here, let the water out, and then it's good to go for later on. So I put 35 pounds of air pressure in the bladder, so that's ready to test. I also added this going into the sump pit over here. That way when we do drain it, it'll have some place to go, because it's a lot more than a couple buckets can handle. Normally you'd run this right into the septic system, and then when you're done you just let all the water go into the septic, but we don't have the septic in here yet, which is fine. There's definitely cases where you have to do that. So I guess now it's the moment of truth. We'll see if all my joints hold up. It's pretty easy to get a leak, but if you're meticulous about it, usually you shouldn't have one. I've definitely had a fair share of leaks over the years though. And that's why it's good to test the system, because you really never know. Especially vent connections, because you don't really pay as much attention to those. At least most people don't anyways. And under normal circumstances it would probably be alright, but it's good to know that you have a leak, because you don't want to find out years down the road when you have rotted wood. So I still haven't gotten the other end of that hose to put into the test fitting, so we'll just do it the old-fashioned way, fill up the vent pipe from the roof, and we'll see where it goes. We got a leak coming out of this test fitting right here, but that's just because the threads on it don't seal. So you have to put Teflon around there, and I've used the Teflon a few times now. I probably should have put new Teflon on there, but we know that that's not a big deal. This is the first time I've ever used this system here, and I didn't realize that these are actually supposed to go on the inside of the wall, so they're not sticking out. So I'm just going to change these over real quick. Just flip them over. That way there's only that much sticking out instead of all that. Usually I do this all with drop ears, and then I come out with 1/2-inch brass pipes, but I'm trying to find a way to not have any more threaded connections than I need to. and also no solder joints either. Since this video is getting kind of long, I didn't bother putting in the details about installing these supply lines here. But basically, you got one set right here for one bathroom, one set right there for the other bathroom. You come over here, there's going to be a manifold over here. And although this looks like spaghetti right now, that's only because I have everything hooked together. And then I have a gauge right here, and I got 100 pounds of air to test it out. So then I got another set of lines going all the way over to the kitchen over there. Whenever I'm installing supply lines on an exterior wall, even with this nice ICF wall, which is a lot better than regular framing with insulation, I still like to put the supply lines on the inside of the wall so that it's not in the wall at all. So you come out from the floor to do that. And although it looks a lot better to come up through the wall and have a stub out coming from the wall, it doesn't really matter because it's underneath the sink. Nobody's gonna see it. So in this first bathroom right here, we got shower valves right here, going up to a rain head. Got the vanity stubbed out and the toilet. And like I said, this is the first time using this setup here. So I still think it's gonna be a little bit of a pain with this right here when you got either drywall or like my dad's doing, which is mostly wood. You can still get a flange that's big enough to cover that, so it should be fine. The only thing I don't really like about this is the fact that This is sticking out a lot, and then you put a screw in there and that's sticking out a lot. I suppose you could put like a roofing nail in there and then it wouldn't be protruding so much, but I don't think it's really gonna matter here anyways. This is underneath the vanity. Nobody really sees that. Nobody really pays attention to that. For behind the toilet, it might be worth putting a roofing nail there just because that's kind of seen there. And then the other bathroom here, got the stub out here. And then for the toilet. And then in here, there's gonna be a bathtub. So the only thing I didn't install was the spout going down. And just because we gotta order some pieces for that. But other than that, this is ready for inspection. We also have a rain head for in here. So like I said, originally they were gonna do a 1.5 bath and they were only gonna do 2 rooms in this house, but they ended up doing 3 rooms and 2 full baths, or 1 3/4 actually, because the one is a shower, so that's considered a 3/4. So that kind of crunched everything together. So these bathrooms are a lot smaller than they were originally gonna be. But my parents are okay with that, so it is what it is. One thing you want to pay attention to when you're installing a rain head like this up in the attic, you want to make sure that you got a lot of insulation over that, because that can freeze up there. Unless you're insulating the actual roof and not the ceiling. But they're insulating the ceiling here, and they're going to do like 18 inches of blown-in insulation. So there'll be 18 inches on top of that. So it shouldn't be a problem here. But just in case it is, I also sloped it. I sloped it so where this pipe comes up, I sloped it downhill to go to here. So every time they take a shower and they shut it off, it's going to drain the water out by gravity. So there'll be nothing in any of the pipes that are up there. And I left a loop instead of using like elbows and stuff. So the only connection up there is right here. PEX piping holds up pretty good to freezing. The only thing that doesn't hold up is the fittings, because they're brass. So they will crack, and I have seen that. But the pipe itself, it'll take a major amount of abuse with expansion and contraction from freezing and stuff before it actually ever ruptures. I've never even seen it rupture before. I've only seen the fittings crack from freezing. So like I said, I have 100 PSI in the lines right now of air. So one thing that you definitely want to make sure that you do is spray down all these threaded connections with soap and water. And it'll be obvious if there's even a tiniest leak. It'll make huge bubbles next to the leaks. So I sprayed down these threaded connections as well as any elbows like this, anything that's above the basement, because that's going to be covered up. I've never seen one of these fittings leak before, but just in case, there's only a few up here, so it doesn't take long to just spray them down with soap and water. And I use pipe dope and Teflon on these fittings just to make sure they don't leak. So if you guys were wondering what all the ruckus in the background was about, my dad was over here doing work on this room here. So he's almost done with it. This will be the first room that'll be completely finished in this house. And what he did is a trimless design. So there's no trim. The jamb comes out and it's mitered to the panels on the wall. They're mitered to go up to it. So there's no trim at all. Which that's what he wanted. That's what he was aiming for. It looks nice and clean. It's a lot of work, but it looks good. Even around the door jambs here, it's the same thing. There's no trim. Everything is mitered to the corner. And everything in here was trees that he got from Andrew and then milled them up, planed them. He let them sit for a few years too. You can't just mill them up and plane them. So he had to stack them away under cover for a long time and then planed them down, routed them out to have a shiplap design, and then install them. So most of these are spruce and pine. There might be a little bit of hemlock, but I don't think there's too much. So he's gonna have some can lights in here. And he did like a, kind of like a faux tray design for the ceiling, where he took a board and put it on a 45 with some miters on it to make it look like the ceiling is a tray ceiling, but it's not. It was a way to finish that up so that there's not a big gap there, which I'm sure would be fine even if there was, but this looks a lot better. Cope the corners. So my dad is a finished carpenter by trade. That's what he's done mostly. So this is up his alley here. So if you guys want to see the video on how I did this, I'll leave a link in the description. And by the time I get this video out, he'll be done and he'll have his video out too. Like I said, I'm still going to be installing the septic system here. Probably coming up in a few weeks. But we're done with all the plumbing and electric that I need to do in here. And I'll see you guys on the septic install video.